Hi, we're Group 6 and I'm Olivia Harrison.
I'm Annalisa Swanson.
I'm Jack Borth, and today we will be talking about gene editing using CRISPR-Cas9 to potentially eliminate castration in the pig industry.
Like most animal production industries, castration in the swine industry is a very time-consuming process. Annalisa, what is castration?
Olivia. Castration is the surgical removal of the testicles from boar piglets. This here represents a castration knife that is used in your commercial sow farms today. In general, piglets are castrated within the first 7 days of life, and at the same time that other procedures such as needle teeth clipping, tail docking, as well as iron shots are performed. Why do we castrate, Olivia?
Without castration, meat quality can be affected due to the presence of boar taint. Boar taint gives off a foul odor and taste to the meat due to the hormones stored in the fat. Because of this, foods that are made from boars in the U.S. undergo a lot of processing, such as this pepperoni here, to mask its effects. However, in other countries, castration is banned, so a lot of their meat does contain boar taint. In these two pictures, you can see that there is not a difference in color between a pork chop from America and one from the UK. There would be a difference in taste, however, because the pork from the UK would have a higher androsterone and scatoli levels, which would affect the meat taste and give off an odor while the meat was cooking. These hormones would be stored in the fat, which you can see here on the edges of the pork chops.
But what does boar taint and meat quality have to do with genetics? Pig breeding expert Benny Van Handel predicts that as consumers' demands begin to shift away from traditional castration, producers have to look for alternatives, with one of those alternatives being gene editing using CRISPR.
CRISPR-Cas9 is a protein that has a strand of RNA, which can be seen in this red strand here, which is synthesized in the lab. Within the Cas9 protein, a DNA cutting protein. The protein moves along the DNA strand until it finds a sequence that it is supposed to modify. The protein will then unwind the DNA, and the RNA will match up to the DNA sequence undergoing modification. Once it is matched up correctly, the Cas9 will cause a double-strand break in the DNA sequence.
The cell tries to repair the break in the DNA sequence. However, the repair process is more likely to introduce additions or deletions into the DNA sequence. These variations from the original sequence are likely to disable the gene, stopping replication, transcription, and translation from occurring in that region.
In his article from Pig Progress, Van Handel explains how boar taint is linked to the levels of androsterone and scatol deposited in the fat. The goal of gene editing here would be to lower the production of these hormones in order to decrease the presence of boar taint in the meat.
If we use these cups of water as an example, we can see an estimation of the amount of androsterone and scatol seen in the fat of a barrow on the right compared to that of a boar. Annalisa and Jack are lowering the amount of hormones from that of a boar. This would be what would occur if CRISPR-Cas9 were successful. The levels of the hormones would be either in between or closer to the levels of hormones that are found in a barrow.
Gene editing has the potential to redesign the pork industry, and the future of commercial production could have a lot more intact males in it, like you see in this video.
Today we talked about what boar taint is, where you can find it in the U.S. like in pepperoni, and how it can be found in most pork in the U.K. and other European countries.
We also learned how CRISPR-Cas9 can go in and modify the gene sequence, disabling the genes and therefore eliminating the need for surgical castration without sacrificing meat quality.
Gene editing could be a solution to castration, but we will just have to wait and see.